Acid-base equilibrium, dilution of strong acids and bases. In this tutorial, we will be going over the definition of dilution, general dilution formula, and 4 worked examples. Dilution is the addition of a solvent to an existing solution. Adding water to an aqueous solution at a given concentration results in a decrease in concentration. The moles of solute remain constant, but the total volume of the solution increases. Given the general formula, M1V1 is equal to M2V2, where M1 is the initial molarity, V1 is the initial volume, M2 is the final molarity, and V2 is the final volume. Let's do some examples. Hydrochloric acid, when ordered from a chemical supplier, has a molarity of 12. Determine the volume needed in liters to make 500 milliliters of a 3.00 molar solution. The first thing that we need to do is identify each variable in the stimulus. So the initial molarity is 12 molar. The final volume is identified as 500 milliliters. And the final molarity is identified as 3.00 molar. The unknown here will be the initial volume. Then we're going to write the general formula for dilution. Next, we will rearrange the formula to solve for the unknown variable. Then we will plug in the numbers from the stimulus, and when we calculate the answer, we find it to be 125 milliliters. Notice that the answer is in milliliters. The stimulus states that the answer needs to be in liters. Therefore, we need to set up a conversion to get our answer into liters. We know that 1 liter is equal to 1,000 milliliters, and our final answer is 0.125 liters. Let's look at another example. A student is required to make 250 milliliters of a 0.50 molar NaOH solution from a 50 milliliter stock solution. Determine the initial molarity of the stock solution. So our unknown variable is going to be our initial molarity. The final volume needs to be 250 milliliters at a molarity of 0.50 molar. A 50 milliliter stock solution is provided as the initial volume. So we start by writing the general formula for dilution. We'll rearrange this formula to solve for our unknown, which is M1. Next, we'll plug in the values that are given to us in the stimulus. Solving for our unknown, the initial molarity is 2.5 molar to the correct number of significant figures. Let's look at another example. Determine the concentration of a solution where 175 milliliters of a 1.6 molar solution of nitric acid, HNO3, is diluted to 1.0 liters. We start by identifying each variable in the stimulus. So our initial volume is 175 milliliters. Our initial molarity is 1.6. Our final volume is identified as 1.0 liter, and our unknown is our final molarity. We write the general formula for dilution. We rearrange this formula to solve for the unknown variable, which in this case is M2. Before we go any farther, we need to notice that the V1 and the V2 are in different units for volume. In order to move forward in the calculation, these units need to be equivalent. I am choosing to convert the 175 milliliters into liters. So when I do this conversion, that will result in 0.175 liters. After this conversion, we're going to substitute the variables into the formula to solve for the unknown. Once we complete the calculation, we find that our final molarity is 0.28 molar to the correct number of significant figures. Let's do one more example. A lab requires 750 milliliters of an 8.0 molar potassium hydroxide solution to be diluted to 3.0 molar. Determine the final volume of the solution in milliliters. We are given an initial volume of 750 milliliters at a molarity of 8.0 molar. Our final molarity is 3.0 molar, and the unknown is our final volume. We start by writing the general formula for dilution. We'll rearrange this formula to solve for the unknown variable, which in this case is V2. Next, we'll substitute in the given variables to solve for our unknown. We'll complete the calculation and solve for V2, which we find to be 2,250 milliliters. So this answer needs to be rounded to the correct number of significant figures. We can represent this answer to two significant figures in either scientific notation or standard notation. So what did you learn? We talked about the definition of a dilution, the general dilution formula, and then did 4 worked examples. Need more help? Feel free to contact me. Have a great day.